So hello and welcome to Makers Demo Day. Happy Friday, everyone. I'm looking forward to seeing all the wonderful presentations today that I know that the devs have been working hard on. So we can kick off now. As you know, we are makers and our mission is to transform lives and organizations by bridging the gap between tech industry needs and underdiscovered talent. A little bit more about our makers. They are a dedicated group who are passionate about tech and they're continuously growing their skills in development and collaboration. They've gained essential technical skills and they've also improved their problem-solving techniques and continuously expanded their capabilities. During their time at bootcamp, they've built a strong foundation before diving into their chosen specialism, applying their knowledge to real-world projects. And through teamwork, they've honed their ability to communicate, innovate, and drive projects forward. So just a bit of housekeeping. I ask that you please stay muted for the duration of today's presentations. They should last around 10 minutes each. And if you have any questions, feel free to put them in the chat, either while the team is presenting or when they've concluded and they're finished, and they'll answer your questions if you have any. And so let's hear a little bit more from our tech coach, Ben, who will fill us in about what the devs have been working on. And yeah, so pass over to Ben now.
Hi, everyone. Thank you for coming. So just a quick introduction to what the devs have been doing in this 8-week block of their cloud course, where they've covered a variety of systems. In fact, introduced in the first 6 weeks to over 12 different AWS systems, but also in the last 2 weeks may have found and learned some more which I may share with you later. What we have been presented with is both teams are working on the same project, and the project is a tricky one where they are given a problem and they have to find, first of all, the details of how they can solve the solution, what the problem is, before they get on to actually solving it themselves. They're given a situation where there's a vet hospital which has been using a provider called HOSP, who unfortunately are not doing a good job. HOSP now know that the vet hospital wants to replace them, but our teams have been brought in to try and fix things in a short time before a full replacement can be brought in. So they're in a situation where they have a hostile provider where they will not be provided with various details and are not getting cooperation. And they're trying to improve reliability for the vet hospital as much as possible within this time. So I'll let them tell you more and I'll pass straight over to Group SHHM.
Good afternoon, everyone. Can you all see my screen? You should be able to. Perfect. Well, thank you very much, everyone, for attending. My name is Mohamedou. I will be representing Team SHHM today. Unfortunately, Sam is not going to be with us today, but I will let my other two colleagues introduce themselves.
Hello, I'm Harika.
Hello, I'm Hassan.
Thank you very much for that. So as Ben explained, we were tasked with improving the critical systems reliability. Looks quite simple in theory, but it was very important to keep reliability highly available as the system was live and we could not afford for it to go down. The first thing we did was we looked at the initial infrastructure and we realized that we had a load balancer. We also had a server to which we did not have access. We had API documentation which explained how the app was supposed to work. And we had the knowledge that the current server was not performing the way the client wanted. So based on this very little information, what we did was we started to essentially create a completely new server, which we thought would be more reliable than the existing one and would therefore tackle the reliability issues once we had deployed it. However, we consulted with our coach about this approach and he made us understand our initial understanding was completely wrong. So we gathered as a team and we actually started to map the resources that we had instead of just going straight into work. And we came to find that the only thing that we could control within this environment was the load balancer. There were other elements within the environment that unfortunately escaped our control. So there was not much we could do about that. With this in mind, we built a diagram that showed how the initial infrastructure was supposed to work. So it was quite simple. It's built around the load balancer, which is the only thing we could control. and it just shows that a client sends a request, which goes through the load balancer. This request is then sent to the server that hosts the app, and then from that onwards, a response is sent through the load balancer again to the client. This showed that the load balancer was key, as all the traffic was going through it. So it was very important for us to be able to at least monitor this load balancer to see what was happening, what was going right and what was going wrong. However, up until this point, none of us had actually worked with a load balancer. So we did some research as to what the purpose and functionality of a load balancer was. And in this case, we found that the load balancer simply distributes traffic, and it can redirect traffic to new resources we may create. Knowing this, we focused on trying to find a way we could monitor what was happening within this load balancer. And the first thing we did was creating an S3 bucket where we could store the logs that were going through the load balancer. Initially, we thought that this would be enough, but after accessing the S3 bucket, we saw that the data was very difficult to be read by at least us. So we researched as to how we could make this data more readable. And that's how we ended up with the idea of pairing our S3 bucket with Athena, whereby we will be able to organize our data into a database and be able to query our data using SQL queries. This was very important as it saved us a lot of time because we could track down the errors, the time when the errors happened, and we'll be able to find more information about the errors. This led us to our next finding, which was the frequent and consistent 500 error codes. Initially, we did think that, okay, it could be that our server is just being overloaded and we just need to distribute the traffic into a different resource so that the server is not working so hard. And that's how we came up with the idea of auto-scaling. Now, auto-scaling required us to duplicate the original server. However, as I said at the beginning, we didn't really have access to this server at all. So we ended up creating an EC2 instance that we thought hosted the original app hosted in the host server, but unfortunately it didn't. And once we directed traffic to that second server, our reliability took a heavy impact. So we decided to revert back to the original setup and do more research about 500 errors and what could be causing it. Interestingly enough, in the API documentation, we found that 500 errors were just internal server errors, and that the solution may be to just try again. So with that in mind, we got together again and we discussed how we could implement this retry logic. We knew that we couldn't access the host server, so that was not possible. However, we found that we can use Nginx as a reverse proxy to retry attempts or retry requests twice at least before they are considered to be unsuccessful requests. Now, this helped us during Wednesday because it made our reliability peak at 98%. Unfortunately, we cannot show it because the average of the whole day was affected by the auto-scaling attempt from the previous day. Once we had this first taste of success, we went into Athena again to query what was happening in our load balancer. And we could still see that there were 500 errors, 502 errors. So these errors were actually real because our server retried the request several times and it still gives us an error. So after even more research, we thought we could potentially cache all the traffic going through the load balancer because it would decrease the load in the backend and it would just serve cache responses instead of hitting the backend all the time with unsuccessful requests or with failed backend calls. We initially tried to do this using CloudFront. However, we were not very successful at this. We found CloudFront to be a bit complex and time-consuming at that particular point, and it was also very difficult to monitor. We even tried to use Amazon Kinesis and open a data stream to monitor what was happening with this particular resource, but it led us essentially to a dead end. So we stopped what we were doing at that point and we said, okay, all of our traffic is going through Nginx, through that Nginx server that we created earlier. So why don't we just try to do the caching from that point? And this is the point from which Harika will explain what happened next.
Thanks, Mahmoudou. So on Friday evening, after multiple attempts, we realized that our dashboards were not looking very good. And when we assessed everything at our end, we realized that we have made numerous changes to our config files that cannot be tracked. And the reliability of our server became very unstable. So as a team, we decided to terminate all the AWS resources we created and decided to start fresh, as we've broken the system and we didn't take site reliability into account at that point. So we made new plans after realizing the importance of site reliability as to how to work efficiently as a team. And we decided to implement small changes and monitor success. Also have a fallback strategy and to track all the changes that we are making to the configuration file. Next slide, please. So we decided to work in a 30-minute window where we implement some changes, monitor them, and then assess the situation. And as a fallback, what we did was we connected our HOSP server to the load balancer. And we also had the Nginx server, Nginx, where we were making continuous changes and we were monitoring it. And finally, we started using GitHub to track all our changes that we've been making to the Nginx configuration. After some research, we understood that caching can be achieved using Nginx. So we made few changes to our Nginx configuration, which included like implementing retry logic, and we were caching successful and failed responses and also used stale cache for the backend errors and timeouts. We also enabled retries for post requests, as post requests are not cached by default and caching post requests has some risks. After implementing these changes in a fresh config file, our dashboards went green and they hit 100%, but only for a few hours, and it came crashing down during the out of office hours. One of us have noticed this and quickly connected HOSP server back again so the reliability doesn't drop even further. Next slide, please. The next day, our team's morale was very low after a short-lived success. We tried making so many changes to the Nginx file. For example, we tried caching 200s for longer periods and completely eliminating caching 500s and some other changes, but it made no effect and our reliability kept dropping. On the next day, our team did a lot of thinking, and after assessing, we realized that the changes we made were not successfully deployed. And we also noticed a few things like our retry logic that we implemented was wrong. And the EC2 instance we have been referencing in our Nginx file has been deleted. So we quickly made all those changes along with the ones that enable retries for the post. And after making final changes, our dashboards went green and remained stable. This is our final high-level infrastructure where we had S3 bucket connected to the load balancer, and we used Athena to monitor the logs. And then we used Nginx connected in our EC2 instance, and we continuously monitored it by logging into the EC2 instance. Next slide, please. So our key takeaways from this is, after breaking the system, we realized that site reliability is paramount and also safe implementation is key. And it is very important to make small changes, iterative, and then continuously monitor if they were successful or not, and have a fallback strategy always. And also we realized how important it is to track all the changes that we make, and we use GitHub in this scenario to make our changes. Thank you. Any questions?
Thank you.
Okay, if no questions at this time, I can't see any in the chat. and maybe some will come up at the end, but I will, well done again. I forgot to say earlier how well both teams and how hard both teams had worked on this 2-week project. But I'd like to then pass over to Team Cheppy to do their presentation.
I think we have a question in the chat.
Oh, we do now. I'm really
Yeah.
sorry. Question from Paul. I like that you get to enable you to roll back changes if needed. Did you make any changes that only partly helped? Or any difficult decisions about leaving a change in or taking it out?
Yes, there certainly were moments where we had a Nginx configuration, which, for example, when on Wednesday of last week, we had an Nginx configuration that yielded great results, but we were not able to make it stable enough. So even though it helped, it was not consistently good. So yeah, that was, for example, one change that only partly helped. And decisions about leaving a change or taking it out. I think the whole decision of reverting back to the original setup after a week was probably the hardest one we did as a team, even though it allowed us to make a lot of progress during the second week. But after 5 days, to see that you don't have success, you don't really know where you're going, to sort of ditch all of that work and say we're going to restart again is a little bit hard, but it was needed and yielded great results as we can see today. So yeah.
That's great, thank you. All right. So again, thanks again, Team Cheppy, Team SSHM. And now if you'd like to welcome Team Cheppy.
Hi everyone, let me get my screen up. Okay, so we are Team Cheppy, and we first want to introduce ourselves. My name is Hannah.
Hello, I'm Piers.
Hello.
Hi there, I'm Chindi.
And welcome to our Cloud Engineering Reliability Project presentation. So I'll do a very brief project overview because it's already been overviewed. The HOSP site reliability project aimed to significantly improve the reliability of a veterinary hospital server, which was known to be unreliable and sometimes entirely offline. We started the project at around 96% reliability with the goal of reaching and maintaining 99% reliability while preserving the site functionality as much as possible. We spent our first day on project organization, starting with our team name. Our initials made a great acronym from the start, so we proudly called ourselves Team Cheppy. Next, we built a team charter to define our personal goals, how we work best, and to set a schedule for check-ins and team retros. We used Trello as our system to organize and assign tickets within our team and agreed to use it to also store notes and findings along the way. It was a great way to visually see the task that we wanted to tackle and have team members pick up tickets that aligned with their learning desires. As a third party brought in to increase the reliability of an existing system, we faced some challenges that we needed to overcome. At the start, we knew that the HOSP team wouldn't likely release their source code and wouldn't let us into their web server. We also didn't have access to the IT user traffic gateway. We therefore only had access to a load balancer to make any changes. During our limited conversations with HOSP, we asked them for information about their database location and structures, yet HOSP was very uncooperative. We talk later in the presentation about how we overcame that hurdle. HOSP was helpful with one of our requests to have a test user and password, but that was the only time they helped us during our project. With the limited information we had, we constructed a project outline to guide us to a successful solution. As shown from the previous slide, we first organized our team. We then started stage one of researching the various issues and challenges we needed to solve and the tools inside of AWS and outside AWS that we could use. After some initial research, we moved to stage two, where we set up several observability tools to help us diagnose those issues. Once we had some leads from our logs, we started stage three, where we carefully made changes to the system and tested several different theories and reliability fixes, while also adding some security measures. To wrap up the project, we created project reports and diagrams of the successful system architecture to provide useful information to potential stakeholders. And now I'll pass it off to Pierce.
Thank you so much. It became clear from the beginning that we would need to get a better picture of what were causing the issues so we could understand better what we needed to do to fix them. The first port of call was to run a ZAP scan to find any vulnerabilities. We were hoping we could fix some easy to resolve security issues to improve reliability. However, we wouldn't be able to address these until later in the project. With the test user generated by HOSP, it allowed us to get an insight into how the API was being used. It also exposed further security risks, which we may not have found had we not got access to the HOSP website. As the HOSP system was using AWS, we began looking into the different tools AWS offered to improve reliability. However, to do this, we needed to start looking into getting better visibility of the issues. We primarily used 3 tools to get as much data as we could. We started using Athena fairly early on in the project, which helped us understand what errors we were getting and then guided us as to what errors should be made a priority. We were also able to use it for live monitoring for any change we had made to see if it affected the reliability in a positive or a negative way. Shortly after, we implemented CloudWatch. We used this to understand how much load was on the servers and the load balancers. This information let us understand how much each work of the individual services we created were under. This helped us identify where the bottlenecks were and what we could do to try and improve it and stop it happening further. Later into the project, we implemented CloudTrail. However, this didn't give us any further insight into how to improve reliability. Being a small team, we didn't really see much benefit from it. However, in a larger team, which may be inside HOSP, they may benefit it from long term, as they may have many engineers using AWS tools simultaneously. I will now hand it over to Ella.
Thank you, Pierce. So at this point, you're probably wondering what our process was. So first, we set up an EC2 instance using the HOSP server as its image. We could see lots of traffic heading to the HOSP server, so we thought by creating 2, we could link them up and distribute the load. Did this work? No, it didn't at all. All we'd done was create 2 independent servers that didn't communicate with one another and meant we couldn't access the HOSP's database within the new server. This meant no increase in reliability because the load didn't change, so we had to switch tactics. Then, using Athena, we found we were having lots of 400 errors on our server. These were coming from malicious IPs and they'd completely flooded our website. We did ask HOSP if they could block these IPs, thinking that all of that traffic was causing them low reliability, but HOSP weren't cooperative and wouldn't make that change. So we looked further into why and moved on to other methods of improving it. What finally worked, well, first to find that out, we looked more at Athena research. We found that all endpoints retrieving information were returning 500 errors. This led us to believe that the HOSP server was unreliable in responding to requests for this information. Based on this observation, we researched what we could do to fix it and came across information about a reverse proxy. This would intercept all the traffic headed to the HOSP server and direct any requests received to the relevant areas. We first implemented a very basic Nginx reverse proxy. We did see a slight improvement when we did this, but through further Athena inspection, we found that we were still having some of those annoying 500 errors. This made us realize we need to change the configuration files to retry the request several times before actually returning a 500 error. During this time, we also changed the caching so that any information received from the base server was stored on our new Nginx server, meaning any duplicate requests for the same information didn't need to go back to the unreliable HOSP server. These weren't the only changes we made. So in order to increase our security and reliability, we did the following. So we set up a second Nginx server so we could balance the load between 2 functional servers. This way, if one went down, the other could pick up what the slack from the other one. We set up a firewall to filter out good and bad traffic. We set up CloudFront so that if a lot of requests were failing on the Nginx server, CloudFront would pick that up and divert through the API gateway and the Lambda function to work in a similar way to how our Nginx servers were working. This was put in place as a fail-safe just in case anything ever went wrong. We also set up our load balancer with 2 individual target groups, both of the EC2 instances, to ensure a 50% load on each of these. We also obviously implored secure communication through a HTTPS listener. We set up an SSL certificate on our servers and prevented any server leaks and CSP headers. So you might be wondering how this impacted us. So we saw our reliability increase from 96% to consistently above 99%. And you can see on the picture as well, we did reach 100, which was a great joy to all of us. We decreased all our 500 errors so that they stopped completely, which helped the increase in reliability massively. We set up detailed logs, as Piers mentioned, so that we could see everything that was going on in any server, which allowed us to identify any issues that might have come up. And as I said in the previous slide, we did set up HTTPS with a SSL certificate on our servers. And now it's over to Chinti.
Thanks, Ella. Next slide, please. So we put together a high-level diagram to show you what our final system architecture looks like. So the CHEPI scope is bordered in red, and the diagram reads from left to right. So users connect to the traffic gateway, and from there they access the application load balancer. We added a web application firewall to filter out the bad traffic and let the good traffic in. This secured our incoming traffic. We added CloudFront as a global caching and also just to give us a faster service in general. We considered and included an overall failover system using an API gateway and a serverless Lambda function to retry these server errors just a few times to ensure that we weren't missing out on any opportunities to deliver these messages to the service. In a development environment, we proved that we could implement HTTPS using a self-signed certificate, but for production, we recommend a purchase domain certificate. So finally, just like Ella pointed out, we had 2 reverse servers proxying to the HOSP server, and we did this for a few reasons. I'll name 2. So some control over the code, because as we pointed out, HOSP refused us access to the source code. So by implementing these 2 reverse proxy servers, we're able to, from a middleware perspective, manipulate the code before it hit the database. And secondly, also as a contingency for higher availability, just in case we lost like one of the servers. Next slide, please. So this slide shows our resource map with listeners for HTTP on port 80 and HTTPS on port 443. Using rules, we split traffic 50-50 to target the servers. One of the main reasons for this as well is we were trying out a few things and we're able to try some solutions on one server while keeping the server alive using the second proxy server. So that gave us some flexibility, and that's how we were able to keep our reliability so high, because we're testing on partial traffic and holding the service on 50%. As a last call, we left the default rule in the rules, which would take the system back to the day 1 setup if everything else that we did failed. Next slide, please. This slide shows more details of our failure system and how we connected the API gateway to CloudFront and then to serverless Lambda. And this shows how we set it up. We chose Lambda for our failover system because it only fires up when needed. We already had 2 proxy servers running, so from a cost perspective, we wanted to save some cost on the failover side. Only when it's needed would Lambda be fired up and charge us from that standpoint. Next slide, please. So we wanted to show you just a little bit of our traffic trend. When we looked at the traffic, we saw the traffic increasing and we saw some spikes coming through. And this volume guided some of the decisions that we took. For example, the decision to raise and maintain that second reverse proxy to absorb these spike traffics and also to serve as a contingency. Based on the traffic we saw, we knew we needed a second server just to absorb those shocks. We explored auto-scaling. We did create an auto-scaling template, but when we looked at the traffic volume, it did not suggest that we needed to implement this. And also based on the project duration, we decided to stay away from this. And finally, we kept those 2 proxy servers live at all times, like I said, just to maintain that reliability for the service in case one went down, and we used Lambda to save on cost. Next slide, please. So what we asked ourselves is, what would we do if we had more time? So we thought about 3 things we'd like to implement next off. So the first one would be to store image results, one of the requirements of this project. It was a nice to have. We didn't get to it, but if we had more time, we would definitely pick that up. We would also purchase a production domain. That way we could implement a proper SSL certificate for HTTPS security and encrypted communication. And finally, we would improve the authorization process or the notes users within the application. Next slide, please. That brings me to the end of our presentation, and I'm happy to open it up for any questions you may have. Thank you very much.
Okay, I'll give people a minute in case any questions come through in the chat, but again, well done. Oh, and we have one from Andrew. How did you keep track of changes to all the AWS infrastructure? Did you consider using infrastructure as code such as Terraform?
Yes, we did. So when we considered just typical DevOps tools at the start of the project, we thought about the problem, and like Ben pointed out initially, we had to do a lot of research. So based on the project duration of 2 weeks, it didn't give us quite a lot of time to create things and tear down things using Terraform. However, we did implement GitHub because we wanted to keep a tight control of code revisions. So we used GitHub to collaborate with coding, but we did not implement Terraform just due to the time limitations of the project.
Great, thanks, Shinji. And a question from Adam. If you should do it again, what would you do differently? And they also congratulate you on your presentation.
You want to take this, Hannah, or do you want me to take it?
I was just gonna say that I think in my mind, I think maybe looking at the logs a lot more carefully. And I think as we went along through the project, we started to get more and more specific with what we were querying for and what we were looking for in the logs. So if I were to go back and do it again, I think setting out maybe more of an outline of everything we wanted to discover and kind of doing that in a more organized way, as opposed to as we're iterating through making the changes, maybe doing that more towards the front of the project.
That's great. Thank you. So again, thank you both teams, and thank you for everyone's questions. If I pass back to you to Anna.
Yeah, so a huge well done and congratulations to both teams. It was lovely seeing all of your presentations, seeing your technical skills, and also just the teamwork and collaboration, which you've involved yourself in, which has been lovely. Yeah, so that's a wrap. Happy Friday, everyone. Enjoy your sunny weekend. This Makers is on summer break next week, so the recording of this will be on our YouTube probably the following week, before the Friday. And yeah, lovely meeting you all. Take care.